Okay, let's look at something visual. Let's talk about independence in R3. What does that look like? Okay, so we'll assume that U, V, and W are in R3. Okay, we've seen before that U, just one vector, is independent if and only if U is not 0. Okay, that's true anywhere. Okay, U, V is dependent if one of the vectors, either U or V, is a multiple there. Okay, so that looks like, here's my origin. So if you have like the two vectors going like this, okay, if neither one is a multiple of the other, then you have independence. But if by chance, if say U goes off like this, then the set here would be independent or dependent. Okay, so dependence looks like, oh, I want to be more, I'm going to change this to a W just so something a bit more coherent. So UV is independent, VW is dependent. And we'll say this is an example. Okay, so dependence, I guess not always, but dependence looks like this. We'll say often. Okay, one vector is a scaling of the other one. You could also have something like W0 is dependent. Don't forget that about that case. Okay, how about three vectors? We'll say consider. For your consideration, consider UVW where all vex are not 0. Now, it's a bit hard to draw, but if I have U like this and V like this, now if I have W that lies in the same plane as U and V. So what I mean by plane is I form this triangle to help me visualize. Form this triangle. Now there's exactly one plane, an infinite flat sheet of paper. There is exactly one plane that contains this triangle. Now if W happens to lie inside of it, inside the plane, so, you're going to have to, whatever, it could go like that. So there's a plane containing the triangle. Now if W is in that plane, so we'll put that as a condition here. W is in the same plane as U and V. Okay, in this case, U, V, W is unnecessarily dependent. Why is that? Since, well, you can see by the picture that, W is going to equal, some linear combination of U and V. That's because it's in the same plane. So AU plus BV minus W equals 0 minus W is a non-trivial dependence relation. Okay, I want to note here that what this means is W is in the span. Let's put this somewhere else, sorry. So W is in the span of U and V. But how about if W is not? If W is not in the span of U and V, not in the same plane, the triangle, we'll say, so you have something like, it's hard to draw on a flat screen, but if you have, what are my letters there? U on top. So origin, U, V. So you can imagine W maybe coming out of the paper like this. So here you can just imagine that U and V are on the screen and V is kind of, sorry, U and V are on the screen and W is coming out of the screen. Then U, V, W, and UVW is independent. Oops, I got something missing. Okay. This is not what I want. This is not what I want. I want this to be W naught in this spin. So if W is not in the spin, sorry about that. Another change I want to make to your notes is I think I want to change my wording here. I want to change my wording right here. So if you could erase U and V. So erase all that. Let's go back. So erase, go over in green maybe. So W is in the same plane as the triangle. Okay, I'd like that to be your notes instead.